Hello, everyone. Let me just resize my face there. There. Now I'm out of the way. So, what do we got going on here? Well, I'm going to just go over a brief lecture of everything you need to know about this topic. I'm going to be as brief and to the point as possible. So, hopefully, those of you struggling get that last little bit of help you need to make sense of all this, because this stuff is weird. What we have on the screen here are all of our learning objectives for this unit. What it all builds up to is what's on the bottom. Can we reconstruct an accident? If I tell you something about a collision, can you work backwards to figure out how fast the two cars were going right after the crash to right before the crash? And of course, to do that, we need to use kinematics from Unit 1 first semester. We need to use friction forces and Newton's laws, which would be Unit 2 from first semester. We'll need to use our understanding of what momentum is from Unit 3 of first semester. And then on top of that, we're going to build in the new stuff here in Unit 4, which is the conservation of momentum. So let's go ahead and get started. Let's say that I have this example problem. This is the one that we did in class, so I'm using it to help you with your notes if it still doesn't make sense. I have a 5-kilogram block that slides at an unknown velocity. It then collides with a 3-kilogram block. They stick together and slide off together. They slide 1.2 meters before they stop, and the friction coefficient is 0.4. Can we describe the momentum as it moves within the system? All right, so the word describe means please tell me everything you know about the topic. Good. Momentum. Momentum is our measurement of how difficult it is to get something to stop. The equation for it is P equals mass times velocity. Great. System. The system means the two things we care about. In this case, the two blocks. I don't care about the table. I don't care about the world. I don't care about the Earth. I don't care about the solar system. I just care about these two blocks. All right, let's see what we got. I would say that when the two blocks collide, some of the momentum from the first block goes into the second block. Now they both have momentum, so they both move away. But this one has less momentum than it started with, so it's going slower than it was before. It's going fast, and now they're both going slow. All right, what kind of collision is this? Well, this is an inelastic collision, specifically a sticky collision, because they literally stick together and move together as they go. All right, that one's pretty easy. But why do they slow down and stop after 1.2 meters? This is because of friction. If you remember, all surfaces are rough. They got these nooks and crannies. And as they are squeezed together, they interlock. As I try to move them past each other, they grab onto each other, which is we call friction. And that's what's slowing the blocks down. There we go. Can we now calculate that acceleration of the slowdown? Yes. And it requires a bunch of stuff from Unit 2, dynamics, forces. What it boils down to is this. I know that the only force on my blocks is friction, which means my friction force is also my net force. Net force is always equal to mass times acceleration. Friction force is coefficient times mass times 9.8. So I can cross off mass on both sides if I want, and that gives me that the acceleration is going to be equal to the coefficient multiplied by 9.8. All right, that's always true. That is an always true statement. It's not always true, but it is always true in my class. All right, I plug in my numbers, I get an answer. I told you the coefficient of friction in this case was 0.4. So you multiply them, you get an acceleration of 3.92 meters per second per second. I slapped the negative on there just to remind us that we're slowing down. All right, now that we have the acceleration, can we use that to find the velocity right after the crash? If all I know is how far it went after it crashed, can I figure out what that speed was right away? Yes. And to do that, we got to realize that we're saying our V final here is 0 after it's come to a stop, after it traveled a displacement of 1.2 meters, with an acceleration of negative 3.92 meters per second per second. We are looking for that starting velocity. Right after the crash, at the beginning of the skid, what was that velocity? Well, we're going to use this equation. Vf squared equals Vi squared plus 2 times A times delta X. That's from unit 1. I rearranged it for you there at the bottom. You plug in your numbers, you get an answer. 9.408. You have to remember to take the square root, which gives you 3.06 meters per second. But now I have to remember, okay, well, is this 3.06 meters per second forward? Sorry, your direction forwards or backwards? In this case, forwards, so it would be positive 3.06. Can we calculate the momentum? Ooh, see, now we're in our unit 3. Well, momentum is mass times velocity. It's how difficult is this going to be to stop? Well, to do that, I just do my mass. Well, this is the 2 blocks together, so it's the 5 and the 3 together make an 8, times the velocity of positive 3.06 to give me a total momentum after the crash of positive 24.5 kilogram meters per second. Momentums. Okay, here is the new bit. Here is the unit 4 bit. Can I use this to find the momentum right before the crash? Yes, because the momentum before the crash will always be equal to the momentum after the crash. So if the momentum after of the 2 blocks is 24.5, the momentum before of the 2 blocks will also be 24.5, right? But that's split between the 2 blocks. Oh, see, but our 3 kilogram block doesn't have any momentum because if you remember, it has a velocity of 0. So all of that 24.5 came from the 5 kilogram moving block. All right, well, can we calculate that velocity then? Yes, again, we can, because momentum is just mass times velocity. So here I'm taking what we talked about last slide and I'm building on it. I know that the initial momentum is going to be mass A times VA plus mass B times VB. Except I know that that velocity of the second block, of block B, is 0. And that's where the 3 times 0 comes from down there. All right, well, if that's 0, that means that 24.5 equals 5 times my velocity. I just have to solve for that velocity. I divide both sides by 5, I get an answer. My 5 kilogram block was traveling at a velocity of 4.9 meters per second in the positive direction. Wow, that was a lot. But you're never going to do all of this alone. This is a group project. You would do this whole project with your notes, with your teammates to help you. And I posted this picture on Google Classroom. This is a guide to show you what's going on. The only thing you got to remember is that we're working. Come on, let me write. Doesn't want to let me write. Whatever. In any case, we're working from here up, from friction to friction, then acceleration to acceleration, then V2 to V2, then PI to PI, and then finally to V1. We're working backwards from what it looks like on this screen. That's all you need to keep in mind, and you should be able to use this exact roadmap to solve both case file 1 and case file 2. Hopefully that was at least a little helpful. Thanks for watching.